Topics in post-harvest technology. Forced air cooling, a precooling method. Precooling is the rapid removal of heat from a commodity before it is placed in storage or before it is shipped. The key idea here is that it is rapid, and one should think in terms of minutes, not hours, to remove the heat from the commodity. Precooling helps to maximize shelf life by rapidly reducing a product's respiration rate as well as its rate of water loss. Forced air or pressure cooling is a method in which air pressure is manipulated to cause cold air to flow into and through boxes or bins of product, cooling it. Often, a forced air system is set up within a pre-existing cold room. A false wall, known as a bulkhead, is built to create a space known as a plenum, and fans are mounted in the bulkhead wall. In this schematic, you can see the bulkhead with a fan mounted in it. The plenum is behind the bulkhead between the outer cooler wall and the bulkhead wall. There are openings in the bulkhead, and a row of pallets is placed to either side of each opening. In this photo, there are two openings in the bulkhead. The bulkhead is the white wall. There are also white lines painted on the concrete floor. These were placed on the floor to assist forklift drivers when lining up pallets. A row of pallets will be placed to either side of each set of lines to create a channel that is centered on the opening in the bulkhead. This photo shows a forced air system in operation. Notice that a tarp has been placed over the pallets to seal the channel so that air cannot move down the channel into the plenum space. Something to consider is that pressure is no more than the force exerted by molecules hitting a particular area at a particular time. Think of a room in which you're hitting a wall with ping pong balls. The more balls that hit the wall at any given time, the greater the pressure or force exerted on that wall. When the fans that are mounted in the bulkhead are turned on, their curved fins scoop air molecules from within the plenum space and push those molecules into the cooler room. Since there are now less molecules within the plenum space, there is less air pressure in the plenum. So going back to the schematic, the fans are on and they're pushing air into the room. This creates a higher pressure area. The plenum space becomes a lower pressure area. Nature doesn't like imbalances. It wants everything to be on the same level. As a result, the higher pressure air will try to flow back into the plenum space to neutralize the pressure imbalance. That is why we have the tarp. The tarp prevents the air from going down the channel between the rows of pallets to neutralize the pressure difference. Since the air cannot pass through the tarp, it causes the air to flow through the sides of the boxes or bins or flats where there is a heat exchange and the product is cooled. In this photo, you can see the height of the pallets, but you can also see that each flat has two vents. These vents allow the cold air to easily flow into the flats and around the product. The air eventually moves to the channel between the pallets, then down the channel where it passes through the opening in the bulkhead and is recirculated. In many coolers, there are refrigeration units associated with the fans so that as the air moves into the plenum, it is cooled before it is then pushed back into the room. However, if you don't have refrigeration associated directly with the fans, as long as there are refrigeration units in the room that can remove the heat from the air, the system will function properly. This is a video clip, but before it is started, notice the three forced air stations. On the left, we have an operational system. In the middle, we have one that's partially built, but not yet operational. Notice the channel between the pallets. On the right, there is a station that has no pallets. Observe that at the opening in the bulkhead on the right, there are bits of paper that are held against a screen. The screen is specifically there to catch bits of paper, which are labels and tags that have come off cartons and pallets through the daily activities within the cooler. What's holding the paper bits against the screen is air pressure. The air is rushing through the screen, but it cannot go through the paper, so it pushes the paper pieces against the screen and holds them there. You may have noticed that the cooler is actually rather noisy because of all the fans that are in operation. You may have also noticed that all the fans were turning, whether a forced air station was in operation or not. That's because the fans help to circulate the air in the cooler space to give a more uniform temperature throughout the storage area. In this photo, a piece of fiberboard was thrown up against the flats. This system is in operation. The flats are being cooled as air is rushing into those vent holes. However, when the air hits the fiberboard, it can't move through the fiberboard, so what does it do? It pushes the fiberboard against the flats and holds it there. If we were to turn off the fan that makes the system function, airflow would stop and the fiberboard would drop to the ground. Typically, the air associated with a forced air cooling system will be maintained in the 33 to 35 degree range to maximize cooling efficiency. So, what are the advantages of forced air cooling? It's a gentle method of cooling, and as such, it's widely adapted for use with many products, from cut flowers such as roses to leaf lettuce. It's relatively easy to set up, as one can use a pre-existing cooler. It's adaptable for use not only in coolers, but on ships, rail cars, trucks, and even in the field using portable units. It does not require the use of waxed or waterproofed boxes, which are more expensive and harder to recycle. Typically, a waxed or resin-impregnated waterproof box will cost 20 to 25% more than an unwaxed box. And at recycling centers, they would have to use special chemicals and techniques to remove the wax or resin so that the fiber could be recycled. Most recycling centers are not set up to do this, so most recycling centers do not accept waterproofed boxes. What are the disadvantages of forced air cooling? It is a relatively slow method compared to other pre-cooling methods, and it's at least 2 to 3 times slower than when cooling with cold water. Incomplete cooling may occur, so the size and placement of carton vents is important. Also, how product is packed in cartons and bins is important. If the product is packed too tightly, rather than air flowing through and around the product, it will flow over the product, and that will greatly reduce the rate of cooling. Unacceptable water loss from commodities may occur. Typically, the relative humidity in a refrigerated storage space will be 70 to 80%. It's considered that the relative humidity inside horticultural products is 100%. So if you have a product with 100% relative humidity in its tissues and air with less than 100% relative humidity, water is going to flow from the product into the air. To reduce water loss, we may use plastic overwraps. Think of cauliflower or lettuce heads wrapped with plastic film. We may use room humidifiers. In this photo, this is a forced air system that is functioning because one can see that the tarp is pressed against the cartons. Notice the PVC pipe above the tarp. There are atomizer heads embedded in the pipe. When the water is turned on, a fine mist of water is emitted into the air, and that helps raise the relative humidity to reduce water loss from the cooling product. Likewise, in this photo, we also have water pipes and atomizers above each forced air cooling station. Air velocity should be optimized. It's counterintuitive, but the faster the air velocity, the less the water loss. This has been determined through experimentation, and it's been found that with very fast-moving air, the heat exchange that occurs at a faster rate than the water loss from the product. So the net result is actually less water loss with fast-moving air than with slow-moving air. Summary points. Pre-cooling is the rapid removal of product heat before storage or transport. Pre-cooling is necessary for many commodities to maximize shelf life. Forced air cooling, which uses fans to manipulate air pressure, causes cold air to flow into cartons or bins and around product, quickly cooling it. Forced air cooling is widely used, relatively easy to set up, and is a gentle pre-cooling method, but is relatively slow compared to other pre-cooling methods. Water loss may be a problem, so precautions may need to be taken to avoid excessive product wilting and softening.